All right, hopefully this works out okay. We had some technical hiccups in first period. All right. There we go. There's our first example. Is everybody able to see that okay? Fantastic. Okay. Awesome. Thank you guys. All right. So the whole reason that I said that we had to do this one today and we couldn't just skip it was what? What do you notice about this problem? What stands out about this particular example? It is top heavy. Thank you, Erlen. Yes. Right here, we are top heavy. The degree of my numerator is higher than the degree of my denominator. Sorry, it zoomed way in there. Let me fix that. All right. So I have this top heavy equation. Does that numerator factor at all? Is there anything that you know of that will multiply to 3, but add to 1? Multiplies to 3, adds to 1. Erlen, yours is close, but I think you switched it around there. Yeah. Nothing. I mean, the only things that multiply to 3 are going to be 3 and 1, and there's no way I can combine a 3 and a 1 and get 1 by adding or subtracting. So since I know that numerator does not factor, I know that there are no holes. Because nothing can cancel out with my denominator. All right, so then I go looking for my x-intercept, because we can have more than one. And these are going to be the zeros of my numerator. Well, we already said that it does not factor. So what would I have to use then to find the x-intercepts if it does not factor? I would have to use quadratic formula. All right, so let's try that. I have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So x equals -1 plus or minus, what am I going to end up with underneath that radical? What will I have underneath the radical when I simplify this part right here? -11. So what does that mean? I have a -11 underneath my radical. I'm trying to find my x-intercepts. Where is it going to touch the x-axis if I have a negative under the radical? It does not. Absolutely correct. This is imaginary. And so we do not have any x-intercepts. We only have imaginary roots. All right, so then I switch my attention then to any y-intercepts we might have. How do I find my y-intercepts?
When x is equal to 0.
Yes. Y-intercepts are when x is equal to 0. So I'm going to have 0 squared plus 0 plus 3 over 0 plus 2. So I can see here that I'm going to end up with the ratio of my constants, because that is the only thing there that does not go to 0. So my y-intercept is going to be 0, 3/2, or 0, 1.5. I'm going to go ahead and put that on the graph. That's the first thing I've been able to graph here. right there. I need my vertical asymptote. I know I'm only going to have one because all I have down in that denominator is a single linear factor. Where is my vertical asymptote going to be? X equals -2. Yes. So looking right here, x plus 2 equals 0. X equals -2. There's my vertical asymptote. So I'm going to go ahead and put that on my graph also over here at -2. And now we're getting to that slant or oblique asymptote. For this, I want to use long or synthetic division. I'm going to go with synthetic division. My denominator, the root is -2. And then I need my coefficients 1, 1, and 3. Going to block that off because that'll be my remainder. First thing I do is pull this first value straight down, which in this case is going to be a 1. And then I multiply -2 and 1 together. I write that down right here. So I add it to the 1 up above. I have -1. Repeat that process. -2 times -1 gives me a +2. I add it to the 3 up above, and I have a remainder of 5. And this is my slant asymptote. It's going to be x minus 1. So what we've just done here, we're not going to end up using that 5 for anything. We are rewriting this original function rule. That remainder would go up on top of my denominator, x plus 2. And then we have plus x minus 1 off to the side. And this is where my slant asymptote comes from, right here. So slant asymptote y equals x minus 1. I'm going to go plot that on my graph over here. So I start down at -1, and then we have a slope of 1. I'm going to draw that in with a dashed line. I need to know that my function does not ever touch or cross that. So just like we did with our horizontal asymptotes, I'm going to take x minus 1 and set it equal to x squared plus x plus 3 over x plus 2. Multiply both sides by plus 2. So my denominator cancels out. I'm going to need to distribute here. So I have x squared minus x plus 2x minus 2 is equal to just that numerator there, x squared plus x plus 3. So I see that my x squareds are going to cancel out. When I combine these two together, -x and a +2x, what do I get? Remember, it's a -x and a +2x. Yeah, I get 1x. So here's 1x and here's 1x. So those are going to cancel, which means I end up with -2 equals 3. That is ridiculous. So there are no points of intersection. With our slant asymptote. All right, I can come over here and graph this now. I've got only 1 point graphed in addition to my asymptotes. So I know that it's going to have to go through that point and it's going to hug my asymptotes. What I don't know is whether it's going to be in this upper section here to the left of my vertical asymptote, or if it's going to be in this little pie-shaped section down here. So I'm going to need to pick a value and substitute in there. What value would you guys like to substitute in for X here? I need to pick something to the left of -2. What value do you guys want to substitute in here? -4 sounds good. So I have f of -4 equals -4 squared plus -4 plus 3 all over -4 plus 2. All right, so I have 16 minus 4 plus 3 over -2. How's that numerator going to come out? 16 minus 4 plus 3. 15. So I have 15 over -2, -7.5. Not much room to write that down. Sorry, guys. So I have an ordered pair of -4, -7.5 that is on this graph. That's going to go just a little bit below where I am, because my graph, if you'll notice, I only go down to -6. But I know that it's going to be down in this section somewhere. If I had a normal 10 by 10 graph here, I would be able to see this better. And it could look like this, or it could come even further in. I'm just not exactly sure, but I do know that it's down in this section because of that point that we just found. All right. There's one more thing that I wanted to show you guys before we talk about any of the inverse and direct variation from 4.6. And that is this guy right here. We are going to write a rational function that meets all of the criteria that they've given us here. Vertical asymptotes, those are the zeros of my denominator. And then it also gives me my x-intercepts. Well, those are the zeros of my numerator. So I can start writing this function rule in factored form, because I know that down in my denominator, I have x minus 3. That goes with my vertical asymptote at 3. And then for the other one, because the vertical asymptote is fractional, that denominator is the coefficient on x. So I have 4x plus 3 for that other vertical asymptote. And then up in my numerator, my zeros, I have x minus 1 for that x-intercept and x plus 2. Next piece of information they gave me has to do with the y-intercept. The y-intercept is the ratio of the constants. I can't see my constants right here. I'm going to need to multiply this out, and then we'll look at what we're going to do with that piece of information. So I have x squared plus 2x minus 1x minus 2. Then do the same thing in my denominator. So I have 4x squared plus 3x minus 12x minus 9. Combine my like terms together to clean that up a little bit. So I have x squared plus x minus 2 over 4x squared minus 9x minus 9. So this right here is currently the ratio of my constants. but I need it to come out to be -5. So it's currently 2/9, but I need -5. So there has to be something that I'm multiplying this by, some number A that I multiply this all by so that I get this ratio of 5 or 5/1. So I'm going to multiply top and bottom by the reciprocal. I'm going to multiply by 9/2. So that'll cancel out there. I have A equals -45/2. So I'm going to multiply the top and bottom of this. -45 on the top, 2 on the bottom. So I'm going to distribute that to each piece. So now I have -45x squared minus 45x plus 90 over 8x squared minus 18x minus 18. Somebody grab your calculator real quick and divide these two and tell me what that ratio is. It's 90 divided by -18. -5. There's my y-intercept. All right, the last piece of information they gave me is about a hole. It has a removable discontinuity, a hole at x equals 0. So that means that there is a factor of x in the numerator and denominator that would cancel out. So I'm going to multiply this top and bottom by x, and that will give me the function that I was looking for. So -45x cubed minus 45x squared plus 90x all over 8x cubed minus 18x squared minus 18x. All right. Does anybody have any questions for me at all about this one or the previous one before we look at variation for our last couple of minutes? All right. I'm going to pull our schedule up so that I know exactly when the bell is going to ring here. My apologies that I didn't already have it up. Right. It is not going to pull up in that format. Cool. Does anybody remember exactly what time the bell rings here for this class? I want to say it's 8:50. Yep.
8:50.
Awesome. Thank you. I thought I was correct there. All right. So when we're talking about variation, anytime they tell me this first piece, S is, Y is, Z is, that's my equal sign there. So S equals directly proportional means I am going to multiply, or it does not need to be on the bottom of a fraction here. I also, however, need to remember my constant of variation, which is K. So S equals K, then directly proportional to the square of X. So this gets multiplied by X squared. This is the first piece right here that your homework asks for. And then it wants you to find K, and they give you values to substitute in. We have 24 that we can substitute in for S. And then we have 2 that we can substitute in for X. So I'm going to have 2 squared. So 24 equals K times 4. So what is our value for K then? Value for K is 6. This is the other thing that your homework asks you for. So it wants the formula written with the given variables and the constant of proportionality, K, and then it wants you to find K. Last year on the fall final exam, IU asked students to then write the equation that represented that relationship, which is a lot of words to say they just wanted to see you substitute that K value back in so that you could write one single equation for the relationship that it's describing right here. All right. So I want to look at one more with you, one that has inverse proportionality. So here it starts off with Z is. So I have Z equals. Go ahead and write that down here. I need my constant of proportionality. I need K. It is directly proportional to the product of X and Y. So I'm going to multiply X and Y together. But then it says that it is inversely proportional to the cubed root of W. If it is inversely proportional, it goes on the bottom of a fraction. Erlen, this is a dual credit IU course. IU is the one that writes the final exam for the fall and the spring. That's why I was mentioning what IU wanted, because that was not included in the textbook. It's so I didn't have it on the homework because the homework comes directly from the textbook. But I'm going to talk about what I've seen IU do on their final exams so that you guys are prepared and understand what they mean by any of those different pieces. Because again, I don't write that exam. I don't even have it yet. I have to wait to get it from them. And then I administer that in December. Does that make sense? All right. So this would be my formula. Again, this is what I'm going over. This is the only day that we have to cover this right here. All they want you to do is take K and substitute it in there. That's the only piece that's not in your book that IU asked for on the exam last year. After you find K, sub it back into that formula right there. Let's see if we have enough time to actually find this. Z is 16. Nope, doesn't look like we do. But I would substitute these values in. So in the place of X, I have 6. In the place of Y, I have 4 over the cubed root of 27. And then I would solve for K that way. All right, guys, I will see you in class tomorrow. We're going to review for your test tomorrow. Please make sure that you finish up any and all homework and that you begin working on the review so that we have plenty of things to talk about in class tomorrow. I will see you guys then. Have a great rest of
By
your day.
chance, does K equal 2?